here's one way to come to terms with the law of sines. So the law of sines relates angles on a triangle. Let's call that angle alpha and the side opposite it A. This side, this angle beta, this side length B, this angle gamma, this side length C. And the law of sines essentially says that if you have that height, there are two ways to come to terms with that height. One way, let's call that H1. One way to come to terms with that height is to say, well, that is related to this triangle. So sine of alpha equals opposite over hypotenuse, H1 over C. Or if you wanted to clear denominators, you could say H1 equals C times sine alpha. Another way to do it is to look at this triangle. Well, clearly that's related to sine of gamma. Sine of gamma is opposite over hypotenuse. So let's write that as H1 over A. So if I was going to clear denominators here, I'd write H1 equals A times sine gamma. Well, if there's two different ways to write H1, they must be equal. So that means C times sine alpha must equal A times sine gamma. Okay, and working by dividing both sides by A and C, the A's cancel here, the C's cancel here, and I get sine of alpha over A. So somehow the ratio of the sine of this and this side is equal to sine of gamma over C, the sine of this side in ratio to this side. Okay, so that's sort of part of the law of sines. Now, the thing about taking a height is you can do it on any side. So let's just imagine for a moment that I'm taking the height this direction. Just for kicks and giggles, pretend like I actually got that at a 90-degree angle. We'll call that line H2. Okay. Well, you can play the same game with H2. So considering beta, sine beta should be opposite over hypotenuse. So sine beta should equal H2 over A. But somehow sine alpha should be opposite over hypotenuse as well. So sine alpha should equal H2 over B. Well, then clearing denominators, I get A sine B beta must equal H2, but H2 also must equal B sine alpha. Playing the same trick I did down here, I'll set those things equal to each other. So A sine beta equals B sine alpha. I'll clear these terms out of the numerator actually with AB, AB. So I'll get sine beta over B equals sine alpha over A. And of course, since sine alpha over A is the same here, you'll see that sine beta over B is the same as sine gamma over C as well. And this is sort of the classic form where you've got all three set together. All three ratios are equal.